Video is for Advanced Algebra 1 and um, moving on to topic 4. And we're going to be solving systems of linear equations. And the first method that we're going to learn to do that is the graphing method. And really, we just learned the graphing method because it shows us the three things that can happen when we have a system of linear equations. And so we will get right to it. So we spent most of topic 2, some of topic 3, graphing these linear equations. And so now here we are at that point again. So both of these equations are in slope-intercept form. So as you know, we start with the y-intercept. The y-intercept is at -2. And then the slope is 1/2. So I'm going to rise +1 and run +2. I could also rise -1 and run -2 and still land on the same line. And then we draw in that line, and you're going to want to extend it all the way out both ways. Then our next equation, the y-intercept is at -7. 2, 3, 4, 5, 6, 7, just the very bottom of my graph. And the slope is 3, so I'm going to rise 3 and run 1. And it's going to look like this. Okay, and obviously this is the point of intersection. So the solution to this system of equations is this ordered pair, and it's at that ordered pair is at 2, -1, or x equals 2, y equals -1. Okay. This next one, numbers are kind of large for my graph. I'm going to count by 2s on the y-axis. So 2, 4, 6, 8, 10 would be here. And then I'm going to rise 2 and run 1. And I counted by 2, so I'm only going up 1 space. So there's that first line. Then the other one, the y-intercept is at 1, which is actually at the halfway mark because, again, I counted by 2s. And then the slope is down 1 and over 4. Down 1 and over 4. And or up 1 and over 4. And we draw this in. And this is why this is not a good method. I don't know if I'm headed right towards that or not. But I'm gonna call that the point of intersection. And at that point of intersection, x is -3 and y is 4. I'm sorry, x would be -2, 4, 6. Forgot that I counted by 2s. X is -6 and y is 4. And what I mean by, this is not a good method. If I solve this algebraically, I know the exact spot where those two lines intersect. When I solve these graphically, I'm not sure if that's the right spot or not. I didn't use a straight edge to, really trace it in there good. We just got, that, and we're estimating where they intersect. And 2 more here. The one on the right is the one I'm going to graph first. The y-intercept is 5. 1, 2, 3, 4, 5. Showing off my counting skills again. And the slope is -3. So I'm going to rise -3 and run +1. And that'll give that line a negative slope. Draw that in. Obviously I missed that point, so there again, that's the inaccuracy of this method. With the 15x plus 5y equals 25, I'm actually going to put this in slope-intercept form. I'm going to subtract 15x from both sides and then I'm going to divide everything by 5. And I get negative 3x plus 5. And I go to graph this, and what I notice is that it's the exact same line. Okay, and so what these are called coinciding lines. And when lines are coinciding, that means they land right on top of each other. And and what that means is that the answer is that there are infinitely many solutions. Therefore, infinitely many solutions. So any ordered pair that's going to work in this equation is also going to work in this equation. Okay, and that's what I was talking about before about, there's, when we solve systems of linear equations, there's 3 things that can happen. They intersect, like they did for my first 2 examples. The lines intersect, we get the point of intersection, everything is golden. But another thing that can happen is that the lines don't intersect. The lines are coinciding. And in that case, then there are infinitely many solutions. And there is a third thing that can happen, and that's what we're going to look at next. So if I graph that line on the left is, right now it's y minus 2x equals 6. I'm going to put it in slope-intercept form and move that 2x to the other side. And on the other line, I'm going to do the same thing. It's negative 4x plus 2y equals 8. So I'm going to move the 4x plus 8, divide everything by 2, y equals 2x plus 4. Okay? And oh, you're not seeing that. There it is. There we go. So here's my second equation over here. I moved the 4x and then divided everything by 2. And so 1, 2, 3, 4, 5, 6. And then slope is 2, so down 2 to the left because it has a positive slope, down 2 and to the left. And then we draw that in. The other one, the intercept is at 4. 1, 2, 3, 4. Down 2 to the left, down 2, has the same slope. And, we could have stopped when I got there. The slope of this line is 2. The slope of this line is 2. And those lines are parallel. Which is the third thing that can happen. Number one thing, the lines intersect. We got a point. All is golden. Second thing, we have coinciding lines, and there are infinitely many solutions. Third key thing that can happen is the lines are parallel, and therefore there is no solution. So now when we get to this algebraically, we know that every system of equations that we solve could work out like any of one of these 3, where we get a solution, the ordered pair, we state it, we're done, or we get coinciding lines, and then we say there's infinitely many solutions, or we get parallel lines and we say there's no solution. So any of those things are possible. And that's why we cover the graphing method, really. Not because it's a good method for solving systems of equations. It's not a good method for solving systems of equations. But it does help us see graphically the 3 things that can happen. Okay. We are going to have some word problems in this section, and then I'm going to supplement them a little bit too. But basically we want to try to write, an equation to represent each one. And Rashawn here has saved $150 and adds $10 a week to it. So let's use R of A is, so he's starting with $150. Let's do R of W. It's going to make more sense because it's weekly. And so he starts with $150 and he's adding $10 a week. Keegan, so we'll use K of W for Keegan, starts at $0 and saves $25 a week. So his equation would be 0 plus 25W. But we don't need 0 plus 25W. We can just write the 25W. And it says in how many weeks will they have the same amount of money? What amount of money will they have at that time? And we can guess and check this. Rashawn, Keegan, week. So at week 0, 150, 25, 0. Well, 25, 0. At week 1, 160, 25. Week 2, 170, 50. Week 3, 180, 75. Week 4, 190, 100. Week 5, 200, 125. Week 6, we add 10 here and we add 25 over here. Week 7, we add 10 to Rashawn and we add 25 here. Week 8, 230, 200. Week 9, 240, 225. Week 10, 250, 250. So when will they have the same amount of money? In 10 weeks. And what amount of money will they have at that time? $250. The other way to solve that would have been to graph it, but with those large numbers, just not as easy to do that. The other way to solve it would be algebraically, and that's what I'm gunning for. Basically we want to know when they will have the same amount of money, so we want to set these two things equal to each other. And this is called the substitution method. So 150 plus 10W equals 25W, and then we would subtract 10W from both sides and get 150 equals 15W, and then divide both sides by 15, and W is 10. And we knew that, week 10 is when they're going to have the same amount of money. If I use this method to solve, then I can take that 10 for W and plug it into either of these equations to figure out what the amount of money is. 25 times 10 is 250. 100 plus 150 is 250. And that's it for this section. And basically I said the primary purpose of this section is to see that when I solve a system of equations, whatever method I use, there's three things that can happen. The lines intersect and the answer is an ordered pair. The lines coincide and the answer is infinitely many solutions. Or the lines are parallel and there's no solution. Okay?